Even though you've been taking chemistry for several semesters or maybe even years by this point in your academic career, we still, in organic chemistry, get into a situation where we have to learn a whole new language, a whole new way of describing molecules. This video is a brief introduction into this language, and then there'll be several other videos for you to watch that will help you practice with learning this naming or nomenclature process and getting to know the vocabulary. Here's our first job. We see this molecule right here, and it has 1, 2, 3, 4, 5, 6 carbons on it. And let's say that we have the assignment of naming this molecule. We're taking a quiz or a test. We have to write the name for this molecule. Well, it's 6 carbons in a line, and so we're going to have to go over to our course notes that we might have printed off of the course website. And under the alkane definitions and nomenclature, there is a table here that helps us to figure out what prefix or what root word we need to use depending on the number of carbons that are connected in a long chain with each other. So we said we saw 6 carbons in a row. That means that we are going to use hex as our prefix. And as you go through all of this semester and even subsequent semesters of organic chemistry, you will always be using these prefixes to describe a certain number of carbons, whatever number you have in a given molecule. When we're dealing with alkanes, when we just have carbons and hydrogens in our molecule and we don't have any other special functional groups, then we can put the ending of ANE on each one of these prefixes. So a 6-membered or a 6-numbered chain would be called hexane. If we had 5 carbons in our straight chain, it would be pentane. If we had 11 carbons in our straight chain, it would be undecane, or 12 would be dodecane. So that's how we go about with naming alkanes. And let me just let you know right now in this first nomenclature video that you are going to have the prefixes for 1 through 12 memorized. So if you're taking a test, if you're taking a quiz, it's expected that if your carbon molecule, if your chain has 12 carbons or less in a row, then you should be able to come up with a correct prefix or root word to describe that number of carbons. Go ahead and put that on your list of things that you need to have memorized for this class. Okay, and so we're back, and like I said, we were taking a test or doing an assignment, and we had the job of naming this molecule right here. So we will write down the name for this molecule, hexane. Whew! Nice job. Our instructor comes along and says, yes, nice job. Okay, that felt good. The next assignment that we have is a little bit of a review. You earlier in this course did learn about isomers. We touched on it a little bit, constitutional isomers and stereoisomers. Right now we're going to focus on constitutional isomers, and I'm going to give you a strategy for systematically figuring out all of the isomers for a given molecule or given number of carbons in a molecule. So constitutional isomers are, if you remember, 2 or more molecules that have the same molecular formula. So they have the same number of carbons, the same number of hydrogens, but they are connected differently from one another, and that makes them different molecules from one another. They are not the same molecule, even though they have the same formula. When we're just dealing with carbons and hydrogens, we can always rely on this formula to tell us exactly the number of hydrogens that go with however many carbons that we have. If we start adding double bonds, if we start adding any functional groups, there's a good chance this formula doesn't work anymore, but when it's just carbons and hydrogens, we can rely on CnH2n plus 2. Let's check it out. We have 6 carbons here. This is C6, and so according to this formula, it should be 2 times 6 is 12, plus 2 would be 14. This should be C6H14. And if we go through and count the hydrogens, for sure we see we have 6 carbons, but now we'll count the hydrogens. We have 1, 2, 3 here on the end, plus 2 more makes 5, plus 2 more makes 7, 2 more makes 9, 2 more makes 11, and then on the end of this one we have 3 more, 11 plus 3 equals 14. So this is C6H14. And now your assignment is to figure out all of the other isomers of this molecule. This is 6 carbons in a row, But are there other ways that these carbons and hydrogens can be arranged where you still have this formula and it is a different molecule than this one right here? And I'll tell you the strategy ahead of time. Usually I have people pause and work on the problem, but let me just give you a tip ahead of time. What I like to strategically do when I am working on a problem like this is I know that there are no other isomers of this molecule that have 6 carbons in a row. This is the only one that's possible. So what I'm going to do when I start to look for isomers is first I'm going to take one carbon off and make it a carbon chain that is one less than the original long chain that I started with. So I'm going to put 5 carbons in a row here, and I still have to add a 6th carbon. So I'm going to have to put it in a spot where it won't remake this same molecule. I don't want to put it on either of the ends because that will remake this molecule. But I could put it coming off of the 2nd carbon from the left here as a methyl substituent like that. And now you might feel nervous that maybe I've changed it and it's not C6H14. But if you only are dealing with carbons and hydrogens and you rearrange them in the way that I just did, you don't have to worry that you're changing any number of hydrogens, because I took away this carbon from the end here, and so now this carbon that was in the middle and only had 2 hydrogens now has 1 more hydrogen, right? When I take away this carbon, it ends up being a CH3. And then I'm going to put this end carbon, this methyl carbon, over here coming off of this 2nd carbon of the chain, and it used to have 2 hydrogens, but now it only has 1 because I replaced one of the hydrogens with a carbon. And so when you kind of break apart the molecule and rearrange it like this, it will still always stay the original formula that you are working with. Okay, so now I am going to encourage you to pause the video and work on finding more isomers of this formula, C6H14, that are different molecules than these two. And just keep working on this strategy that I told you about. Check if there are any more with 5 carbons in a row. If you feel like you've exhausted that, then go down to 4 carbons in a row, etc., etc. Okay, so now you pause the video, you worked on it, you're back, you say, I have all the isomers, let's talk about it. Sounds good to me. So let's see, I do want to see if there's any more molecules that have 5 carbons in a row but are different than this one. And I think I could put 5 carbons in a row, and instead of adding this 6th carbon right here, I could put it coming off of the 3rd carbon of the chain, and that would be different than this one. So I'll do that right here. And then, I could do the same thing again. I could move that methyl or that 6th carbon over to this carbon right here, and I guess I'll do that. What do you think about that? Well, look, these molecules, when they're in nature, probably would be in a liquid state, and they'd be tumbling around, folding on top of each other in all sorts of different orientations. I think that this molecule and this molecule are really the same as one another, because I could just pick this one up and flip it over and it would look exactly the same as this one. And the true test to decide if these are really the same as each other is by naming them. And I think I mentioned you're going to get into a lot of rules for naming molecules and get more practice in future videos, but I will just quickly name these two right now and we'll see if it's the same name. So now we have 5 carbons in a row, and then it stops. This is what we call a substituent or a branch. It's coming off of our main chain. So we have to remember from that table we were just looking at, what do you use, what word do you use or prefix when you have 5 carbons in a row? And here it is. If you have 5 carbons in a row, you say pent. So we're talking about pentane molecules when we have 5 carbons in a row. Alright, and so this is a pentane molecule, but if I wanted to just say pentane, it would look like this, right? 5 carbons in a row. Now I have to let my grandma or my sister or whoever I'm telling about my day in the chemistry lab that there was a methyl that came off the 2nd carbon of this chain when I was working in the lab with this molecule. And so the way that I do that is I tell them 2-methyl. 2 means it was coming off the 2nd carbon of the chain, and then pentane. There's a rule that we want these types of numbers to be the lowest they possibly can. And so I could number this chain 1, 2, 3, 4, 5, or I could number this chain 1, 2, 3, 4, 5 from right to left. But if I numbered it from right to left, then that would end up being 4-methylpentane. But if I number from left to right, it's 2-methylpentane. That has the lower number, so that looks better to me. Okay, and then what's this one going to be called? You guessed it, 3-methylpentane. And that would be true whether I numbered from left to right or right to left. It ends up being on the third carbon either way. And now here, I could number from left to right, but like I said, we have this rule where we always try and make this number as low as possible. So if I follow the rules of the IUPAC system, the naming group, then this also ends up being 2-methylpentane, which is the same as this one. And so that is not a new isomer. So far, I have a total of 1, 2, 3 isomers for C6H14. Okay, let's keep going now. I think I exhausted all of the possibilities for 5 carbons in a row. So now I'm going to try 4 carbons in a row, which means I still have 2 more carbons that I have to get onto this molecule somewhere. And I can't put them on the end because that will make it a 5-carbon chain again. So let's see, I think I could put both of them right here, right, on the second carbon. Carbon can have up to 4 bonds, and so this carbon right here now has 4 bonds to other carbons. And it's still C6H14. In terms of hydrogens, there's 3 here, another 3 here for 6, another 3 here for 9. There are no hydrogens here. There's 2 more here, that gets us to 11, plus 3 more here gets us to 14. So like I said, it doesn't matter as long as we aren't adding double or triple bonds or any functional groups. The rearranging should still keep our formula the same. Okay, let's try and name this one. 4 carbons in a row, looks like it will be called bute, B-U-T, so butane. If I only said butane, that would just be 4 carbons in a row, but I have to somehow let my colleague across the country that I'm communicating with know that we have these 2 additional carbons that come off the second carbon of the chain. So I'll do that by saying 2, 2, because this is 1, 2, 3, 4, dimethyl butane. Alright, that's another isomer. This name is different than any of the ones we saw above. Let's see, have we exhausted all of the 4 carbon possibilities? I think if we put 2 methyls on the third carbon, that would be the same as this one, because we could just flip it around and it would look exactly the same as this. And also if we named it, we would just have to number from right to left and it would end up being the same name as this one. So that's the only possibility where we can have 2 methyls on the same carbon. And like I've said, we don't want to put them on the end because that gets us back to a 5-carbon chain. But we could put 1 methyl here and 1 methyl here. And now we have 1, 2, 3, 4, 5, 6 carbons. We have 14 hydrogens. And the name of this molecule would be 2, 3 dimethyl. Still 2 methyls that are coming off our main chain here. Butane. I think there are no other possibilities for 4 carbon chains. 2 here would be the same as that, and splitting them up is the only other possibility. So we could go down and look at 3 carbon chains. Let's see, 1, 2, 3 carbons. And then now we have 3 more carbons we need to add somewhere. I can put 2 of them there. And let's see, I need to still add a 6th carbon. I have 1, 2, 3, 4, 5 carbons. I can't put any more on this one. What if I put it like coming off up here? Maybe that would be a way to get that 6th carbon on there. But we have to be careful because if we did that, our longest chain of carbons in this molecule will become 1, 2, 3, 4. So we basically went back to a 4-carbon chain. And if we named it, we always want to find the longest chain of carbons to start off when we're naming. So this is going to be a butane molecule, and it's basically going to be the same as this one, right? Because if we number 1, 2, there's 2 methyls coming off of that carbon right there. That is not a new one. Alright, so I think we've exhausted all of the possibilities and we've found all of the isomers for C6H14. There are 1, 2, 3, 4, 5 isomers for that molecule.